in this design for recycling case, I'd just like to elaborate briefly on an example where we actually applied all of this in its full detailed granularity to make an informed decision. So gleaning from that circular economy figure from one of my first sheets show that there are various aspects that have to be considered, not only the technology, but also right to the social impact. But for the moment, let's just consider the first three on the left, and I'll just briefly mention the social impact one a bit later on. So using a digital twin to actually go into the detail requires then rigorous simulation tools that are available, which you can use. So what do you need to make this all work? Obviously, to have a digital twin, you need ultimately to go down to the physics level. That's a given. So you need to know thermodynamics, you need to know fluid mechanics, mass and heat transfer, the big data approaches, the digitalization platforms and tools that go around that can be integrated as well to calibrate the models. It's all part of our bag of tools that we already have. The trick is really to bring them all together in a good way. I think this MOOC is also trying to show this to you for the people that will have to help change how we do our business, and therefore understanding that there is more than just drawing a little circle on a piece of paper to circularity. It means the detail as well. This can now be the thermoeconomic cost calculations, which basically is based on the exergy flows, to understand those losses that I spoke about, losses such as dilution losses in a solution, aqueous, slag solution, molten metal solution, and therefore dissipating the exergy. But very important as well are the sustainability goals, which have to also be linked to this. And this is still a challenge, how to bring all the theory, so the physics, rather precise numbers, with social models. And I think I challenge you all, take part, because I think this is a beautiful area where you can really contribute and bringing it all together. On the right-hand side, you will see a publication that we recently did where you can read more about that. Now let's go to the Fairphone example, using the tool that Antti Roine has shown to you. We've used in the past to do design for recycling for the Fairphone 2 and for Fairphone 3. Here's some of the information of the Fairphone 3 and its modules. The idea was modular design. How does modular design improve recyclability? But what is the limit as well? Please recall the metal wheel, that things are connected by design, functionality, but recycling means to unravel that back into the quality that it can go back into this product at the quality required by the functionality of the material. That's true circularity that one really has to understand to do this. You can read all about this in a recent report by Fairphone of just last year, which is, the links are given. You can look at that at your own convenience. And in that, Fairphone actually discusses this. In my opinion, probably the first company that is using this approach, going beyond simple Excel sheet types of calculations, which in fact are simplifying matters to the extent that they don't help society at large. Taking an excerpt from the report, as shown over here, where this was actually discussed, and I said, please go and read that. We also created this we call it element flow, whatever you like to call it, and it's the recovery rate of each of the elements. And this is only a selection of all the elements that actually go into the product. This would be different for different designs, for different flow sheets, etc. So there's not just one answer. And most certainly, it cannot be produced by an Excel sheet. We then went on to publish this a couple of years back with Fairphone, and this is a specific figure taken from that. We call it the recycling index, which showed to you at that time the recyclability of the Fairphone 2 at that situation. The Fairphone 3 has moved up 2 notches into the B category because looking at in this detail. And one very clear message, and I challenge you guys to go and check out the recyclability calculations that are presently being done, which, to my opinion, are overstating things. And that's not helpful. And so we really have to consider this. And a takeout of this specific lecture in MOOC, please go and criticize and look at it in depth.